Okay, in this tutorial we want to determine whether the following integral converges or diverges, and if it converges we want to find the value. So we have the integral, the lower bound is negative infinity and the upper bound is 0. It's going to be x times e raised to x. So the first thing we want to do is say t approaches negative infinity. This will allow us to get a concrete variable. So now we'll have it in this form. And now we can do integration by parts or the tabular method. So when we use a tabular method, we choose a term where we take the derivative and it will ultimately reach 0. So we take x, the derivative is going to be 1, and the derivative of 1 is going to be 0. E raised to the x, we take the antiderivative. Antiderivative of e raised to x is going to be e raised to x, and it continues all the way. Tabular method alternates between positive, negative. So we'll have it in this form. And now we simply multiply. So we have positive x times e raised to the x, negative 1 times e raised to the x. So we'll get this as our antiderivative of this. So now we simply plug in our values. So we have 0 and t. So when we plug in 0, we get 0 for this. But then we get minus 1 for this. So e raised to 0 is 1, so minus 1. Minus parentheses, now we insert t. So we get t times e raised to t minus e raised to t. And now we just distribute the negative. So we'll get it in this form. And using L'Hopital's rule, we'll know that this term right here is 0. So we have negative t divided by e raised to the negative t. This is equivalent to this, right? And now if we plug in t approaches negative infinity, we would get, infinity over infinity. So we can use L'Hopital's rule. So by doing that, we will get the derivative of this will be negative 1, and the derivative of this would be negative e raised to negative t. And so this is equivalent to e raised to t. We simply plug in negative infinity for t, and we would get 1 over e raised to infinity, so 0. So that's why this is also 0. So our final answer is going to be negative 1, and therefore it converges at negative. Therefore it converges, and that's all we need to do.